Hello, I'm Nako from SoftUni, the software university, and I'm here for the part 5 of my free Java Basics coding tutorial, which is a series of video lessons on Java programming for absolute beginners, and it comes with a rich set of hands-on coding practical exercises for each lesson. If you missed the previous parts, please review them first to catch up. In this lesson, I will talk about conditional statements. I will explain and demonstrate how to write control flow logic using the if-else conditional statement, how to compare values, how to write logical conditions, how to implement the body of the if statement, and how to solve practical problems which require branched logic with several cases. I will demonstrate also how to write series of many if-else statements to check several cases in a row. I will explain how to write blocks of code, how the variable scope works inside the blocks, and how to debug your code. As usually, I will show you at the end of this lesson how to solve several coding problems with the if-else statement and how to submit your solution, your code, in the Judge system for automated grading. Don't skip the coding exercises at the end of the lesson. They give you the practical skills and coding experience that you need if you want to become a software developer and start a tech job one day. To learn coding, you should code. There is no other way. Trust me, I'm teaching programming for more than 20 years. You should code to learn coding. That's it. Are you ready? Let's start with the lesson. In the real life, we may have a garden and where plants are located, and sometimes we need to water them. But if it is raining, I don't need to water the plants in the garden because there is rain already. But if it is not raining, otherwise I will have to water them. So in case it is raining, I will do nothing. Otherwise, if it is sunny, for example, I will need to water the plants. So if you want to automate our watering system in our garden, we may have something like this. We may need some sensor which checks the humidity with some controller, and this controller or this small chip which controls the watering system will check the humidity. If it is greater than 90%, it looks like it's raining and we don't need to switch on the watering system. Otherwise, or else, we need to water the plants. So we just say, please water plug.enable or switch on, and it will run the water in the garden to plant the plants, to water the plants. So this is how in the real world scenario we may need to check a condition and take some actions according to this condition. If it is true, we do something. If it is not true, we do something else, another thing. And this is in the real world. In programming, we have the same concept. The concept which I will explain you a little bit later. So let's first start with the logical expressions. Logical expressions are expressions which usually involve the comparison operators to check some condition, and this condition is used to take action according to its value. I will show you how, but first let's see equal2. This is the operator equal, which checks whether two values are the same, are equal. Not equal is this exclamation equal. Greater than is this, greater than or equal is this operator, less than is this operator, and less than or equal to is this operator. This is how they work. In programming, we can compare values using these comparison operators. We can compare values like numbers or some other types which allow comparison, but in Java, we can compare mostly numbers because these operators don't work for strings, for text, for dates, for example. The result of the logical expression is either true or false, and this is an example. We have an int value a equals to 5, int value b, variable b equals to 10, and if we say please print whether a is smaller than b, this will print true. If we print if a is bigger than 100, it will be false because a is 5. 5 is not bigger than 100. If we check whether a is less than or equal to 5, 5 is less than or equal to 5 because 5 is equal to 5, and the result will be true. If we have please calculate whether b is equal to 2 times a, we multiply a by 2, which is 5 multiplied by 2 will be 10, and we compare 10 with b, which is 10, so this will be true. And finally, we check the opposite comparison, whether b, 10, is different than 2 times a, which is also 10, and this is false because they are equal, they are not different. So let me show you this within the Java IDE. I will start this. Oh, I have started already this IntelliJ IDEA. You know, this is our IDE, integrated development environment, and here I have the project from the previous lesson. I will create a new project, which will be named Conditional Statements Java. I had this from other lesson from C#. Okay, it was just a naming conflict. It should be empty. Yes, it is, and this in src source directory we have this. So this is our class, and here I can demonstrate you how to use these logical expressions. For example, I can print out print whether 5 is equal to 5. If I run this, run main, I'll get something like it should be true. It takes some time, but generally the result is true because this is true. We may have something like int a is 5. Please check whether a is 5. And run this. It will say, it says, oh, it takes a lot of time. IntelliJ IDEA is really slow, but that's why. So next I can say int b equals 10. Please s out. Please print whether a is equal to b, and it will say that it's not true. It will say false. Okay, and I can say please whether they are different. It will say true. I press Ctrl F5 and it says true. I can check whether a is less than or equal than b, and it will say yes, it's true because 5 is less than or equal to 10. But I cannot check whether this, because this is string. I cannot compare string, see? I cannot compare int with string. So this will not work. And also, this operator cannot work for strings. Whether a is less than Peter or Mariah, this doesn't work in Java. This works very well in other language like JavaScript, but it doesn't work in Java. So, but we can do this using some other things like string.compare. Oh, it should be something like Mariah.compare to Peter, and it will say maybe 1 or -1. It's -3, which means that Mariah is after Peter. But if they are the same, it will print 0. which means equals. But we will learn about string processing later. I just wanted to show you that we have comparison operators, and when we compare values using these comparison operators, we can build conditional statements and conditional expressions like this one. This is called a comparison expression or conditional expression, and this expression is either true or false. We can use these expressions later to build if-else statements. I'll show you how. But let's mention a little bit the string comparison. If we want to compare strings, we should use the so-called equals. Please, the first string dot equals the second string. I'll show you how. So if we have string A is example and string B is also example, we can compare them by checking A dot compare to B, and it will run correctly. It will say true. No, not compared to, I'm sorry, equals. Compared to will also work, but you should check for 0. This will say true. So if we use this one, it's incorrect. Never do this in Java. No, don't do this. This is bug. It doesn't work. It just checks whether the address of the variable A in the memory is the same like the address of the variable B in the memory. It checks whether these variables are the same variable, which is something completely different than checking the value. I'll show you why this doesn't work. It might work. It will show true now, but it's by chance. It's because of the compiler optimization. But generally this doesn't work, and I will show you. If I have this dot sub string of 1, okay, so I can print that A is plus A plus slash n and B is plus B. Now I will show you that A and B are the same strings. See, A is example, B is example. The equals is false, so this doesn't work correctly, and true here. So it's proven that this is bug. Don't do this in Java. And also IntelliJ IDEA says that string values compared with this are not okay. This says that this will be always true because it's a kind of, it has some kind of optimization. But generally we may have incorrect results if we use equal for strings. In Java this doesn't work. It works very well in all other modern languages like JavaScript or C# or Python, but it doesn't work in Java. Okay, so let's continue with the core of our lesson today, which is about conditional statements. I'll show you how to use simple conditional statements like check something, and if it is correct, do something, do some comments. So we can check certain condition and take action according to the result of this condition. It's something like if some condition is true, please, which is a Boolean expression, please execute this piece of code. So the result of this condition is either true or false, and the code block, this is called code block, this, from the opening curly bracket to the closing curly bracket, this is called code block of code. Okay, this may hold 1, 0 or many commands or actions or statements to be executed. I'll show you how. So assume we have a problem. We want to check whether the temperature of the water is freezing or not. We read the temperature in the Celsius scale and we check whether the temperature is below 0 or not. So we print freezing water if the temperature is equal or smaller than 0, otherwise we print nothing. So if the temperature is 4, we give no output. Otherwise, if the temperature is less than 0, like -2, we print freezing weather. So this is the problem called freezing weather, and I will solve this for you to show you how to use conditional statements in Java in practice. So I will create new Java class, which will be called freezing weather. Okay, and in this class I will create the main method and I will use scanner equals to new scanner. The autocomplete works very well. System.in. Okay, and I will say double temperature. It's complex word. Equals to scanner dot please read the next double value. Okay, and now I can do the magic. If the temperature is less than 0 degrees, I will print something like freezing weather exclamation. Otherwise, I will print nothing. So if I run this program, it will read a temperature, for example, 5 degrees, and it prints nothing. I run it again, -2 degrees, it's freezing weather. 0 degrees, it's still not freezing, but -0.5, it's freezing weather. -20, it's very bad freezing weather, Chicago style. -35 is Alaska style freezing weather or Canada style freezing weather. So this is how it works. If do this, otherwise do this. I can run this through the debugger. I will put a breakpoint and will say please debug this here, and the program will stop here. I can press F8 and I will go here and will enter -2, and now it has this line of code. I press F8, it checks the condition. I can track whether this condition is true or false. It says the temperature is -2.0, F8, and see that the code is executed here and the result is correct. So I can print other more commands here, like please take take a coat, for example. Take your coat to dress yourself and be prepared for this freezing weather. I will run it, and now if the temperature is less than 0, I will print these two commands. So it's -5.6 degrees. Oh, it's freezing weather, please take a coat. Okay, so this is how this works. It's the same thing which I already demonstrated, written here for simplicity. So if the temperature is less than or equal to 0, I print freezing weather. It's not below 0, it's discussable whether it's equal or less than. I assume less than is better. Oh, I'll even fix this here. So, but you catch the concept. We put if, we put a Boolean condition in brackets. This is called conditional condition. It might be it's just some check. We open the bracket, we close the bracket, and we put comment, semicolon, save another comment, semicolon, and this is how this works. I already demonstrated this for you, so we can go ahead and learn how to use better these if conditional statements. So we may use if-else conditions, which means if the condition is false, we may execute another code. If the condition is true, we execute something. If the condition is false or otherwise, we execute something else. This is the if-else construction. So we have if some condition. If it is true, we execute this code block of commands. Otherwise or else, we put else, which follows if. This else is for this if. We execute these commands. This is the construction, and I'll show you how to use this. But first, let's discuss the concept of blocks. Curly brackets in Java introduce blocks. Blocks are just groups of commands. So we may have a block, we may have a command, semicolon, another command or statement, semicolon, another command or statement, semicolon, and closing bracket. And this is a kind of statement. So this is something like a command which internally consists of several other commands. Like, for example, the command open the door may consist of first go to the door, then take the its opening thing and turn it on the right. They then pull the door and many other things. So it's action which consists of several other more simple actions. This is called block, and in case the if statement holds does not have curly bracket, only the code on the next line will be executed. Let me show you what this means. So assume we have a variable called color holding the value red, its string. If the color is red, we execute this statement. Otherwise, we execute this statement. But if we want to execute several statements here, like first, second, third, we'll need to use these brackets. If we have single comment after if or after else, we don't need blocks. Otherwise, we need blocks, and I'll show you how to use this. But in all cases, the commands which follow the if statement starts here and ends here. So this is a statement which consists of if, command, else, command. This is the first statement of our program. This is the second statement of our program. This is the third statement or third command. So we have a sequence of three commands. The first assigns a value to a variable. The second is if else, check something and do some actions according to the result. And the final line is always executed and it prints lemon. I'll show you how to use this in Java. I'll open this example and I will use something like string color is red. The color is red, and if the color is red with double quotes, I will print it is red, for example. It should be not equals, this is a bug, equals to red, okay. Otherwise, I will print not red. Let me run this. Okay, it's red. If it is yellow, it will be not red. This will be executed. But if I want to put several expressions here, like print it's red and I like red color. This will not work. See, it says, oh, it doesn't work. You need this opening bracket and this bracket, and this is a comment. This thing here is a comment or statement which holds internally several other statements, these two lines of code. So now it's not red still, and I can print this, like if I print this not red, I don't like red, this I don't like red will always be executed. See, not red, I don't like red, but if it is red, it will be red, I like red color, this will be executed, this will be executed, and this also, because else is working with this line also, only this one is for the else, and this one is incorrectly formatted and it follows the if. So the if is completed here, and this is another portion of our program. Even if we format it like this, it works the same way. It's incorrectly formatted code. So if we want to put these both comments together, we need these brackets. Without the bracket, the else works only for this. So this is the finally say goodbye, for example. Okay, so finally say goodbye will be always printed and not depending of the color. Depending of the color, either this block will be executed or this comment will be executed. It's not red. So this is how it works, and I'll show you in another example. We have color red. If the color is red, we have blocks of two comments. For example, we print two red things like tomato and strawberry. Otherwise, we print three blocks of comments, like some fruits and vegetables which are not red. So this is how blocks work. They start with this and they end with this, and their content is moved to the right, indented to the right with one tab key. You have TAB tab on your keyboard. It's on the left side. So we have one tab on the right here, and this is the normal formatting, which says that if this is true, these comments will be executed. Otherwise, these three comments will be executed. So you will find that this is very easy once you take some experience. So just for your better, always put this and avoid having else or if blocks without these brackets. It's better to always put brackets. Okay, so we have our next problem to solve for just getting some more experience. It's about writing a program, a Java program, for checking whether a number is odd or even. We read an integer number, and if it is even, we print even. Otherwise, if it is odd, we print odd. This is an example. 4 is even, 7 is odd, and we can do this. Okay, I will take this freezing weather and we'll print Control C, Control V. I want to duplicate this class because I don't want to write the entire program from scratch. Let's get back here. It's something which has a name, it takes some input and does something depending on the input. I will have Control C, Control V, and we'll give a good name. The good name is here, it's called odd or even. Odd or even. So it's class named odd or even. It opens a scanner and it reads, it's not double, it's int, num, which is the next int. Reads an integer, and if the integer is odd, num is odd. How to check where a number is odd? Odd numbers have remainder 1 if we divide them by 2. This is the way. %2 equals 1. And we print that this is odd. Otherwise, we print that this is even. Let's run this and check whether it works correctly. So I'll try 5 is odd. Okay, I run this again. 7 is odd, but 20 is even, and 0 is even, and -3 is odd. Oh, it's even. I'm not sure. No, it's incorrect. But this doesn't work for negatives. It should be like this, different than 0. So now -3 is odd, -4 is even. Or it might be if it is 0, it's even, otherwise it's odd. And this is correct. So we have 4, just a moment, 4, it's even, 5 is odd, 5,000 is even, -1 is odd, -50 is even. It works correctly, and this is our solution. So let's get back here. The solution I had in mind before starting this session is just check for division and the remainder. If it is 0, it is even number. It is number which is directly divisible by 2 equal integer parts. Otherwise, it's odd. So it's even or odd. Okay, let's go ahead with the next problem. It's called greater number. It's about writing a program which finds the greater of 2 numbers. So it reads 2 integer numbers and it finds the greater, the bigger of them. It prints greater number, column, and the greater number. Like if we have 5 and 8, the greater is 8. Okay, if we have, for example, 5 and -8, the greater will be 5. Okay, let's solve this. Greater number. It's very similar to odd or even. So I will copy this. Ctrl-C, Ctrl-V, copy paste. Okay, greater number. And this greater number reads one number, num1, and second number, num2. I copy pasted this one, this one. So if num1 is bigger than num2, which is the bigger number? Num1, which is bigger than num2. So I have greater number and num1. Otherwise, they are either equal or num2 is bigger. So num2 will be the bigger or greater number. I will run this and will demonstrate that it works correctly. So if I have 10 and 20, 20 is the bigger, the second one. If I have 30 and 20, 30 is bigger. If I have -5 and -10, -5 is the bigger number. So this is how this works. It has a check if to something, if this is correct, otherwise to something else. Very simple, but this is how the if-else statement works. This is the way we can solve this problem, and my solution here is very similar to the other solution which I already demonstrated. Okay, so we learned until now how we can check conditions and execute some commands if the condition is true and some other commands if the condition is false. Now we shall learn how to use series of checks or sequences of check, another check, another check, another check, and take different actions according to whether each check is true or false. So we can form more complex conditional statements or more complex programming logic based on sequences of checks. Let's see how this works. It's called series of conditional statements. The if-else statement can be used in a series like this. If some condition, for example, if age is bigger than 100, print you are old. Otherwise, if the age is between 70 and 100, print you are almost old. Otherwise, if the age is between 20 and 70, print your average age. Otherwise, print you're a child. This is just an example. If something is true, run this code. This might be a single line of code or might be some brackets and several lines of code or commands or statements enclosed in this block. Otherwise, check another condition. Otherwise, check another condition. Otherwise, check another condition. So it's true that if this first condition is true, this will be executed and all these checks will not be tested because they are in the else statement, which is normal, which is just the traditional logic we might have if we think a little bit. So this is an example whether we have a series of conditions, but the first condition is true and the others do not execute. So we have a is 7. We check if a is bigger than 4, which is true. We print, oh, it's bigger than 4. Otherwise, we will not get there because a is already bigger than 4. Otherwise, if a is bigger than 5, it prints bigger than 5. Otherwise, it will print it's equal to 7. So here, the output is just bigger than 4, and this and this will never happen because this is true and this is executed. And this is the normal logic you may encounter. So if you want to run this correctly, you may need to first check for bigger than 5 and otherwise bigger than 4. And finally, this. Okay, so just be careful when you build and design your if-else series of conditions to avoid unplanned situations where you check something and the else statement never executes. Okay, this is the next problem we shall solve together. It's called number 1 to 9 as words. It's about writing a program which prints the given number as words. It reads an integer and checks its value. If the integer is in the range from 1 to 9, it's printed as English words, for example, 1 or 7. Okay? If the number is out of range, or for example, it's 100, we print out of range. Here are some examples. We have 7 as a digit, as a number. This is the input, and the output is this text, 7. If we have 10, it's out of range. If we have 7, it's not 7, it's 2. It's a bug in the slides. If we have 2, the output is 2. So this is how this works, number as words. I'll create another program which will be called number as words, a new class. Okay, I'll have here the main method, and in this method I will copy Control Tab this scanner and this reading because I need it. Okay, Control C, Control V. I read the number num, and now I can check if the number is 1. I will print 1. Okay, and otherwise, if the number is 2, I'll print 2. Beware of this. This will not compile, but sometimes you may have this as a mistake. Usually it will not compile. Always use double equals to compare values. I'll copy this because I have some similar, like 3 similar conditions. For I have 5, I have 6, I have 7, 8, 9, and otherwise, if it is not from 1 to 9, it's just out of range. And let's start this, run this. Okay, it's out of range. I have 5, works correctly. I have 1, works correctly. I have 100, it's out of range. I have 0, it's out of range. I have -3, it's out of range. I have 8, works correctly. I have 9, works correctly. I have 10, out of range. So this is how we can use sequences of if, else, if, and finally else. This is a very, very good example how we can check many conditions and print different things or do different actions according to this condition. This is the solution I had in mind before the start of this lesson, but it's very, very similar to the one I already demonstrated to you. Let's talk a little bit about variable scope. Variable scope are the ranges where the variables are available for use, and they are related to the time period where the variable holds some piece of the memory. Because some variables are needed for the entire program, they are called global variables. Some variables I need it for just temporary to make some calculations, and they are not needed later. In Java, variable scope defines the range of lines in which the variable can be used. And the variable scopes is very simply defined. It starts from the curly bracket opening and ends with its corresponding closing curly bracket. It's very simple. See this example. We have current day is Monday. If current day is Monday, we have salary, which is read from the standard input from the console. And here, the scope of this variable declared salary is this block. This block is the block where this variable lives. Its scope is only this block. It's not available here. If we try to access it, we'll have a compile time error. I'll show you this because it's important to see this in action. So if we declare salary here, we don't have salary here. If we declare so it's a compile time error. If we try to run this, we'll have an error. It says, I don't know what is, okay, we need a scanner, but it's not the problem here. I'll add it, the scanner, okay, but it still has this problem that salary is out of scope here. It can be found. If I declare this salary earlier, okay, like this, it will be accessible here. So this definition is here. It starts from this and ends here. So in this entire block of code, we have the variable salary. The scope of salary is this blue block, including here. So now we can use it. So if salary is 0, and if it is Monday, we'll read it. Now this program will work as expected, and we can assume that, for example, the salary is 4,000, for example. Okay, and it's printed. So this is the rule for the variable scope. Scope is the range of lines where a variable can be accessed. Variable scope starts from the opening bracket, curly bracket, and stops in the closing curly bracket. And that's all. It's very simple. Okay, let's go ahead with the next topic. It's called debugging, and I will show you how to use the debugger. I have already mentioned how to use the debugger. This is the way to trace the program and use breakpoints and evaluate the values, but let's show it in bigger details. So debugging in programming is the process of tracking the code execution in order to find some bugs or defects or mistakes. So debugging allows to find where our bugs are because it allows tracking our code. It uses thing called breakpoint. This is called breakpoint, this one, and it's a stopper, a place where the program should stop. We can add a breakpoint using the Control F8. In the IntelliJ IDEA, we can start the debugger with Shift F9, and we can go to the next one, but F8. If we don't remember these key combinations, you can just go here at the Run menu, and we have debug. Do you see? Step over, F8, step into. I'll show you how to use this. Okay, so I'll take these numbers words, okay, and I will put a breakpoint here, okay, and I say debug, or I can use this debug Shift F9, okay, and I'm here and I print, for example, 5, okay, but it's not this application. We debug something else. I'm sorry, this is main. So I should debug. In fact, I run for debugging this project, not this. So I need to debug this one. Okay. So now my program execution is stopped. I am at this point here, at this breakpoint. I can press F8, which means please execute the next command. The next command reads something from the scanner, from the console. I'll print 7, for example. And now I'm here. What's num? Num is 7. Is it true that num is equals to 1? I can use this in the just to see evaluate expression. Is it true that num is 1? It says no, it's false. It's not true. Okay, so I can access the variables here, and I can see what are their values. Do you see this here? I have the scanner. The value of scanner is this one. It's a kind of object. I have these arcs, which are here. This one, this is a variable arcs. This is a variable called scanner, and this is its value. It's a complex object, and num is 7. I can press F8. Press F8 means go to the next command. It's like this. Step over, F7, F8, okay. Check whether it's num is 5, it's not. Else, check for 6, it's not. Check for 7, F8. It says, oh, it's true. Num is 7, so I go here. F8, it's printed and it goes just after this if-else statement at this line. If we had something here, it would be executed, but it's printed 7. So if we have a mistake, for example, bug, I run this program, okay, I run this program, and I print 7, and it says bug. And I don't know where to look, where this bug comes from. So I can run this in the debugger and trace it. F8, I will press, oh sorry, I closed the console, 7, and I execute this step by step. Ah, this is, it prints bug, but it should not be bug, it should be 7. So this is how I can find my problems, my mistakes in the program and fix them. So I fix the bug and I run it again, and it will, now it runs correctly. So it's very easy here, but if we have some kind of expressions, more computations, it may happen that we can find the problems using the debugger. So the debugger is very important and very intelligent tool that developers use to find the bugs. They usually put breakpoints at places where they believe their program might behave incorrectly, and they stop there. They trace the program one by one and find the problems. I'll show you this in many times when I solve some problems and when I have some bugs. I will use the debugger and you will learn how to use it also. Okay, it's your time to solve some problems. Usually in our lessons we'll have some things which I will show you initially with some new material, like today's materials, comparison operators, and using the if-else sequences of checks. And you have to code, to practice all of this in order to learn it, because if you just watch the video, you will definitely learn nothing. You will just know that there is something called if-else, but you will not have the skills. You have the knowledge, but not the skills. To develop the skills, you need to code. So please now try to solve your exercises, which are in the homework section of the learning system, and try to write the code and solve all of them. And later, in a few minutes, I will be back and I will show you my solution. So go ahead, you have some time. Hello again, and I hope that you have some success with the problem solving session. And I will now give you my solution to the practical coding exercises from this lesson. So the first problem is called Guess the Password. It's about writing a program which is checking a password for a certain pre-given phrase, this one, secret exclamation, and it just takes a password guess. If it is this sequence of letters, it says welcome, otherwise it says wrong passwords. So this is an example. The input is secret exclamation and output is welcome. Or if we put the incorrect password, it says just wrong password. Okay, so I open the IntelliJ IDEA and it looks like okay, I'll create a new Java class which will be called password guess. Password guess. Okay, works correctly. And I have a class. I'll put the main method, and I'll have a scanner with control space equals to new scanner of system.in. Okay, Oh, the autocomplete in IntelliJ IDEA is very nice. So the next thing is to read the password. So it would be something like string pass word equals to scanner dot next one. Next one, I said. Okay, and now if the password equals to this thing here, secret, okay, then I will print welcome, and otherwise I'll print something like, oh, it's welcome, it's wrong password. Okay, let's test this. Run password guess.java. It takes some time. Okay, hello. Oh, it's not the password. Let's try this one, secret. It's wrong password. Oh, because I use equals. It's not working like this. Dot equals. I forgot something which I told you many times. The equals operator in Java doesn't work for text. Okay? Let's try again now after the fix. If I use this, it's welcome. If I use this password, it's incorrect. If I use S3CR3T exclamation, it's welcome. So I'm ready, and remember again, use dot equals in Java, because this is how it works. It's stupid, it's bad, it's unpleasant, but this is how it works. So you read the password and you check with password dot equals the other one, and equals operator doesn't work. Okay, if it is correct, welcome, otherwise print wrong password. Okay, let's go ahead with the next problem. The next problem is called boiling water. It's about writing a program to check for boiling water, and the program reads number, the water temperature in degrees in the Celsius scale, and it prints the water is boiling if the number is bigger than 100. It's considered that the water is boiling if when it reaches more than 100 degrees in Celsius, and this is at the sea level, at the sea elevation. If it is elevated higher in the mountain, this number could be less, for example 90 degrees, but this is just for curiosity in the physics. So the water is either boiling or it's not hot enough in all other cases. This is an example, 104.8, the water is boiling. If the temperature of the water is 29, the water is not hot enough. Okay, I will take this password guess and will print Ctrl+C, Ctrl+V. It's called boiling water. The class is boiling water, and it will take a double temperature. I hate this word. Next double. Okay, and now if the temperature is higher than 100, it's boiling water. Otherwise, the water is not hot enough. It should be something like temperature. I hope I wrote this correctly. So I need to test this. 105.33 is boiling water, and 100, it's not hot enough. -5, it's not hot enough. Okay, the water is not hot enough. The water is not, yeah, looks like it's correct. So this is the temperature, degrees, we read it, and it's very, very, very similar to the previous problem, so we are ready. Okay, the next problem is called speed info. We enter a speed, which is a number. We check the speed, whether it is fast or slow. We consider that speed less than or equal to 30 kilometers per hour is slow, and bigger than 30 is fast. 30 slow, 60 fast. It's very similar to the previous problem. So if we want to solve this faster, I will take this boiling water, Control-C copy, Control-V paste, and I will say give a new name, speed info. So I have a cloning of the previous problem's solution of the previous class, which is called speed info. It reads speed, and if the speed is less than or equal to 30, it is considered slow, otherwise it's considered fast. Let's run this, right click, run. I'm waiting for this to be compiled. So 35 kilometers is fast, 140 kilometers per hour is fast, but 25 kilometers per hour is slow. That's all. It's very easy. This is how it can be implemented, but it's exactly the same logic. So we can go ahead with the next problem. The next problem is called area of figures. It's about writing a program to calculate the area of certain figure, which might be a kind of square, rectangle, or circle. The program should read at the first line the type of the figure, for example, circle, reads the size of the figure. It might be one integer, for example, the circle radius, or two integers, for example, width and height, if it is a rectangle. So the figure might be square, rectangle, or circle. If it is square, the size is the radius. If it is rectangle, it needs to read the width and height, two integers. And if it is circle, it should read it's the radius. If it is square, it's the side. The side. Okay, let's draw this. This S is the side of the. If it is square, if it is rectangle, it has width and height, for example. And if it is circle, it has the radius, this size. Okay, but in fact we need to read a string, check the string with some ifs, with some string comparisons, and later either solve the problem about calculating the circle area or solve the problem about reading the size of square and calculating the square area, or reading rectangle width and height and calculate the area by multiplying them. So the area should be calculated, formatted to the second decimal after the dot after this, the floating point decimal separator. Okay, so let's create a new Java class which will be called area of figure. Okay, I click main. I'll need the scanner equals to new scanner control space of system.in. It's fast to write this using the autocomplete in IntelliJ IDEA. And now I need to read the type. String type equals to scanner dot next line. I can't type this. Next line. Okay, finally I succeeded to write it. If type equals dot equals up circle, then I will read the circle. I'll do this later. I want to have the if-else constructions first. If else, if it is square, we do something else. Else, if it is rectangle, I'll do this, and else I will print invalid figure or unknown figure. Okay, so let's write the missing logic. If it is circle, we'll have table radius equals to table.parse it should be double.parse of scanner dot next one. I can't type next, I'm sorry. Okay, or we may use scanner dot next double, but this, if we combine next one with next double, things may get broken. If first we read this and second this will break. If we read first string, first whole line and then this will work. So we can do like this, but for to be more sure about it, it's better to use the other construction. But finally, the double result or area equals, I can declare the area here, double area. I'll declare it here. It's the radius multiplied by radius multiplied by math.p. You know this math.p. It is this constant. Okay. I'll close this. I open this window by Control and the mouse pointer. And now I want to print this, print f, something like percent dot to f slash n and the area. Okay, this is how this works. Let's see whether this works. I'll start it and I'll try it. I have, run. I have circle and the radius is 5. Works correctly. If it is square, it will be something different. I'll copy this because it will be easier. The side is the next double and the radius is the side multiplied by the side, and that's all. And this is the area. Let me check whether if it is square size 5, 25.00 works correctly. If it is rectangle, I'll have width, I'll have height, and the area is width multiplied by height. Let's run this. Rectangle of size 4.5 and 2. It's 11.0. Works correctly. And finally, it's a unknown figure. That's all. Works completely correctly. So, if it is circle, we solve this problem. If it is square, we solve this problem. If it is rectangle, we solve this problem. And finally, we say unknown figure in all other cases. For example, if I have a trapezoid, it's a unknown figure, so I cannot calculate its area. Okay, I believe we solved this problem, area of figures, correctly, and this is the solution I had in mind before starting writing the code. Is just read the the type of the figure, check for square. If it is square, solve the square problem. If it is rectangle, solve the rectangle problem. If it is circle, solve the circle problem. And finally, you may print the area. Well, so in this solution, we have this here, okay? Something like finally, finally, we print the area here, and we don't print it here, and we have double area is 0, and we do this. Do you catch the idea? We have only one printing and many cases here, but we don't have the else case if it is a noun figure. I will return back my solution, but the other one is also possible to have only to avoid duplicated this one, because this one is duplicated 3 times. Do you see? Okay. So this is the solution, and we are ready for the next problem. Our next problem is called ticket price. It's about writing a program to calculate the ticket price, and the program reads the ticket type. It is either student or regular, and the price should be printed as $, and the price like $60, $0. So the student price is 1.00 and the regular price is 1.60. There is a mistake here, because student price should cost less than the regular price. Okay, and if the price is invalid, it's just invalid ticket price, ticket type. So it's just a single if and printing. So it is very similar to our speed info, for example, or password guess, but I'll take this speed info and we'll say copy paste. This will be ticket price, and I'll read the string. Okay, or I can type just var ticket type, and it will be next line. Next line with small letters. Okay, if the ticket type equals normal, it will print the price, which is toward 1.00. Otherwise, I'll take this. Else, if it is student price, it will be 1.60. Shift tab. Otherwise, it's a noun ticket type or invalid ticket type. Okay, invalid ticket type. So let's run this. So I have student price, it's 1.60. Okay, the normal is 1.60 and the ticket is 1.0. The student is 1.0, the normal is 1.60, and the special price is invalid ticket type. Looks correct. So let's see what solution I had in mind. It's very, very similar. If it is student, this price. If it is regular, this price. If it is otherwise, it's invalid ticket price. So I just have if, else, if, else, else. That's all. If, else, else. Okay. As a sequence of if, else constructions, a series of if, else construction. Very simple and okay. Let's go ahead with the next problem, which is called coffee shop. It's about writing a problem to calculate the price for a drink in a coffee shop. The drink might be either coffee or tea, which costs differently, and it might have sugar or not sugar. For example, I have coffee with sugar, or tea with sugar, or coffee without sugar, or tea without sugar. We have just 4 cases. And the price should be printed in the format final price column and the final price with the dollar prefix. So the coffee costs $1, tea costs 60 cents, and sugar costs $0.40. So coffee with sugar should cost 1.40, just like this, and tea without sugar should cost 0.60. That's all. It's very similar to the previous one, but not exactly. So I'll take this ticket price, Control-C, Control-V, and we'll call this class coffee shop. Okay. Oh, it's a mistake. Control-RR. I want to rename this. Shift F6 maybe. Yes. Coffee shop. This and this were both renamed correctly. So the first thing I read is the drink type. Okay, drink. I take the previous lessons, the previous problem solution, because it's easier to start with. So if I have coffee, okay, but I don't know whether I will have sugar or not. So I should have something like price is 1.60. So I start with something like double price is initially 0. I start from 0. If it is coffee, I assign 1.60. Otherwise, if the drink is tea, I will set price to 1.00. And this is the first type. Okay, to start from price 0, to read the drink, and to assign the correct price depending on the drink. Okay, but after that I need to read it will be something very similar. I will need to read the extra, and if the extra is sugar, the price will increase by 0.40. Is this correct? Yes. And otherwise it will not increase at all. And finally I'll need to print f the it's something like dollar followed by %.2f. This is the format string I use, and the price. No, it should be final price. It should be final price, and this one here it's incorrect, and this it should be, oh, let's fix it. It should be final price. I need to paste this. It should be something like this. Okay, 0.60. 0.60 is just a bucket the problem description, right? So okay, this is what we have here, and it maybe needed to be moved to the left, but okay, that's enough. So the idea here is that we need to print this. This is what the problem statement says. So we print this, and we give a second parameters, the price. Okay, let's run this. What this says, I don't know. It's just some kind of coloring. But generally, I will try to order coffee with sugar as a start. Hey, give me the program. Coffee. Oh, it's invalid ticket type. No, I want to run coffee shop, not ticket type. It was the previous. class, the previous solution. So I need coffee with sugar. $2, 1.60. No, it is 100, the coffee, and the tea is 0.60. Okay, I'll try again. Coffee with sugar. It should be 1.40. Okay. Oh, the sugar is 40. Okay. Coffee with sugar, 1.40. Final price 1.40. Okay, I'll start it again. Coffee without sugar, $1. Okay, and tea with sugar, it's $1. Okay, and tea without sugar should be 0.60. Tea without sugar, 0.60. Oh, looks correct. We don't have else here. We don't check for invalid, but it's not required by design. We may have here else, something like invalid drink, and I should do this return, which stops the program execution. It returns out from this main method. Let me show you. So if I want, for example, iced tea, it says invalid drink. Okay, and here else if extra dot equals of no, I do nothing because it's free. But otherwise, or if the extra is not null, I should say invalid extra and return. So this is my final solution, which also handles invalid drink situation, and it also handles with extra, which is different than sugar and null, and will give a problem. So if I order whiskey, it's invalid drink. But if I order a tea with ice, it's invalid extra. But if I order a tea with sugar, that's correct. If I order a coffee with nothing, it's correct. Looks like this works correctly. So we can see what solution I have prepared. We read the order, we read the extra, and if the order is coffee, we set the price. If it is 3, we set the price. If it is something else, we print error message and return. If the extra is sugar, we increase the price. We add additional value of 0.40 to the price. And finally, we print. This code doesn't handle the error situations, but I have shown you already how to handle them. Okay, so what's next? The next problem is called valid triangle. It's about checking whether 3 sides can form a triangle. So let's start from here. In math, if we have triangle and it has 3 sides which build it, they have a length of A, a length of B, and a length of C. But if it happens that C is bigger than A plus B, okay, if A plus B together are smaller than C or equal, this is not triangle, because if it is too small, if A and B are too small, if these sides are too small, they cannot create a triangle. So the idea is check whether 3 integers can form a triangle. So we should check if each side is lesser than the sum of the other 2. If this happens for all the sides, the triangle is okay. But if some certain side is bigger than the sum of the other two, it's invalid triangle. So this is an example of valid triangle 3, 4, 5, and invalid would be something like if we have here 25, for example, because these are 7, but this is 25. So we have 3, 4, and 25. It's obvious that we cannot create a valid triangle using these three sides. So let's solve this problem. It's a little bit more complex than the previous one. It will be called valid triangle. Okay. So in the valid triangle, we'll have the main method. We'll say scanner, control space scanner, new scanner of system.in. Okay, and we read the site. So double site. Okay, a equals to scanner dot next. Oh, I cannot type next. Okay, I'll copy this 3 times. Sorry, Control C V V 3 times. A, B, and C. So what will happen if A plus B is less than or equal to C? Is valid or invalid? We have two sides which together are smaller than the last one. So this is invalid. Invalid triangle. Also, if we have A plus C less than B, it's also invalid. But I should have else, because otherwise I may encounter a double invalid triangle. I need to print just one output message. Otherwise, if A plus B plus C is less than A, it's also invalid. And finally, if this happens, if the first, the second, and the third side are correct, the triangle is correct. Something like this. I use double. Should be done with integers, but it will work as well, 3 integers. Okay, let's see whether this works or not. So I have 3, 3, 4, 5. It's valid. Okay, if I have 3, 4, 25, it's invalid. If I have 104 and 5, 1000, it's invalid. Looks correct. I can do something else. If this or this or this, I have invalid. But we didn't have learned already this. This is called OR, logical OR, logical OR. We'll learn about this in the next lesson, just to demonstrate that this works, and this makes your program shorter and more readable. 3, 4, 5 works correctly, and 134, it's invalid. Okay, so I'll return back this solution, because this is what you should do with the skills you have today. Okay, so this is another solution I had in mind previously. I have a Boolean variable which initially starts from true. We consider a triangle is valid until proven the opposite. So if I find that A plus B is less than C, so A plus B is, no, it's not less. A plus B, okay, yes. If A plus B is less than C, so if C is too long, this is A, small B, and very long C, we say the triangle is invalid. If A plus C, if B is too large, too long, sorry, we set is valid triangle to false. And if A is too long, we set invalid to false. And finally, we print the result, is valid or invalid. So we have if this, print valid, otherwise print invalid. It's very similar, but I can do this. So boolean valid is true. If this happen, valid will be false. And if this happens, valid will be false. And if this happens, valid will be false. And finally, if valid, I'll print this, otherwise I'll print valid, otherwise I'll print invalid. This is another solution. See, it's just I consider valid. If I find invalid side, either C, B or A too long, I change this variable and it holds whether it's valid or not. So if I have, just a moment, 3, 4, 5, it's valid triangle. But if it is 345, this is too long, so it's invalid. Okay, this is the solution, and this was the last problem. So I'm happy that we have successfully passed this lesson, which was about the conditional statements. And I already explained that the logical expressions are built using a comparison operator and some operands, some values, so we can compare, for example, if h is less than 100, or if, for example, if the temperature of the water is less than 100, it's not boiling, things like that. So if we create this comparison, we can use if or if else statements. If something, do some comments, otherwise else, do some other comments. You have seen how to use this, and we can use series of if else checks to implement more complex change of comparison, change of conditions, chains of conditions. Okay, and we explained what is a block, this thing which starts from the opening curly bracket and continues and holds some comments, 0, 1 or more, with semicolon after that, and stops with the closing. It's all starts with opening bracket, curly bracket, and ends with closing curly brackets. So variables defined between two curly brackets have the scope and are valid only here. So in this here, A, B and C are valid from this place until this place. If I put a bracket here and a bracket here, A, B and C here will be unavailable. So this is the variable scope and blocks. And I have shown you how to use the debugger and breakpoints. I will repeat this again. I put a breakpoint by the mouse click, I say debug, and here I say A, F8. Okay, I read. Sorry. Okay, I will read ABC and we'll stop here with the debugger. It will be easier. Okay, I read 3, 4, 5, and here I can trace the valid. Valid is true. Currently F8, this is false, this is false, this is false. So valid is true, so I print this. So I can train the code execution step by step, one by one. And if it behaves incorrectly, I find which line is the problem and I fix it. So this is called debugging, and it's implemented by using the debugger and the breakpoints. So this was the entire content I wanted to transfer to you as knowledge and skills, and I hope you have solved, or you will solve your assignments. You write the code in order to get not just knowledge, because if you watch the video you'll get knowledge, but also the skills, the practical skills of coding. So focus on your homeworks if you didn't do this, and I'll see you for the next lesson where we'll explain more complex things about conditional statements. Did you like this code lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free videos, tutorials on computer programming, Java, software engineering, and many others. Get free access to the practical coding exercises and the automated judge system for these code lessons to evaluate your code from the exercises you write. Get help from the mentors and meet other learners. We will answer your questions. And it's all free, completely free. So join now.